Hello everyone, in this lesson we're going to learn about ionic bonding. So we'll cover ion formation in nonmetals, ion formation in metals, both of which are required for ionic bonding. Then we'll look at electron configurations and even polyatomic ions. We do have a bookwork associated with this lesson, so tomorrow expect that you'll be doing this bookwork in class, the 26 to 33, but we'll also do this do now. What you can do is go ahead and form a paper that goes under classwork, and it's going to have the do now. The assignment for this bookwork will also have a pair up and a summary. So the aim today is what are the properties of ionic bonds, and we will answer that by the end of this lesson. So copy down this do now. We'll do it in class tomorrow, but make sure it's copied down. All right, ion formation in nonmetals. We'll start with the first question. Are group 14 to 17 nonmetals considered stable, and why? They are not considered stable because they do not have full valence shells. And if you're in group 14 to 17, that means you're on the right-hand side of the periodic table. And for instance, elements in group 14 have 4 electrons in their valence shell. For instance, carbon has 4 electrons in its valence shell. And elements in group 17 all have 7 electrons in their valence shell, or specifically fluorine has 7 valence electrons. So the type of ion they become is a negative ion. And I know it's negative because that means they're going to gain electrons to become negative. So what effect would the addition of an electron have on other electrons in the electron cloud? So adding an electron would have an effect because electrons repel each other. So if you're adding in another electron, you're going to be increasing the repulsion. And that's because, electrons repel. In what way would the radius of a nonmetal change as it becomes an ion? So since it's gaining electrons and electrons repel each other, then those electrons would spread out, and that would make the radius of the atom increase. And lastly, these electrons that nonmetals are gaining, where are they coming from? Well, typically they're coming from metals, which are atoms that are the opposite of nonmetals in that they like to lose electrons. So when metals lose electrons, they typically might find their way to a nonmetal. In this slide, I just have an illustration of what I mean by this increased repulsion. So if this electron up here were to sort of like fly in and attach itself here, it would actually cause increased repulsion, which I'm showing with these blue arrows. And that increased repulsion would make the radius of the whole atom expand, like that. All right, let's talk about ion formation in metals. So elements in group 1 and 2 are also not considered stable because they only have 1 or 2 electrons in their valence shell, and they really need 8. What type of ion do group 1 to 2 elements become? So since they're going to be losing electrons, because they only have 1 or 2, so they're going to lose electrons rather than gain electrons. If they lose those electrons, they'll become positive ions. Which reminds me of a joke I just heard. 2 atoms are walking down the street, and one of them says to the second atom says to the first atom, "Oh my gosh, I think I just lost an electron." And the first atom says, "Really? Are you sure?" And the second atom says, "Yeah, I'm positive." I think you can pause the video to finish laughing. And then when you're finished, next question, what effect would the loss of an electron have on other electrons in the electron cloud? Well, since electrons repel each other, if you're losing an electron, that's going to reduce the repulsion and the atom's radius would shrink. Also, and this is a little bit extra, metals tend to lose an entire orbital rather than just losing electrons. So when they lose that entire orbital, it makes the atom even smaller. Therefore, the radius is going to be smaller I'm answering this question here. The radius is going to be smaller because it's losing electrons. And typically those electrons will go to a non-metal atom to be absorbed. So here, if you take a look at this metal atom, this electron is the one that's going to be lost. And when it is finally removed from the atom, you can see that this entire orbital would be gone, and the atom would be much smaller as a result. And it would also be positively charged. All right, so we're going to talk about some noble gas configurations here, but also just to take a look just to make sure you understand what you're looking at. We have some nonmetals and some metals, and these are all from period 2 and 3. So we have the oxygen atom and the fluorine atom, which are right next to each other on the top right of the table in period 2. And then we have sodium and magnesium, which are in period 3 on the left-hand side, so that's why they're metals. And in between them in group 18, period 2, we have neon. And their electron configurations are similar. It looks like oxygen has 2 unpaired electrons, fluorine has 1 unpaired, neon has 8 electrons in the valence shell. Sodium has 8 electrons in that valence shell, but it also has an extra one in a third shell. And magnesium has 2 electrons extra in the third shell. And basically what oxygen does is it pairs up these 2 electrons. So you can see you have the 2 pairs down here. And fluorine, what it does is it just pairs up this 1 electron, and there's its pair. Neon, I think obviously does nothing. It has a stable configuration, and so it doesn't need to change. Sodium needs to actually, it has this electron and it doesn't need that one, so it usually drops it, and that's why you have 1 less orbital here. Same thing for magnesium. You have 2 electrons in that last orbital, but we just drop those 2 electrons, and those 2 electrons are dropped with the last orbital. So with what noble gas does each of the following ions share the same electron configuration? So these are the 4 ions of the 4 atoms, and they all have the same electron configuration as neon. So I will put that in now. And that's actually, I guess I just wanted to write that same answer for all of these. So neon, 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 and neon. So how can the electron configuration of a nonmetal ion be easily predicted? Generally, just write down the noble gas configuration of the element to the right of that element. And if you were going to answer the question for a metal, it would be whichever noble gas is just to the left, but the note would be that it would be up a period and to the left. So what is a polyatomic ion? It is a group of atoms that have a charge, and all the examples that I would give are right here. These are all groups of atoms that have a charge. So if we look at an example for a hydroxide ion, you can find that one here on table E. It's in your reference table. I'll zoom in. The question is what type of bonding exists within a hydroxide ion. So within a hydroxide ion, you have 2 nonmetals that are bonded together, and the kind of bonding that exists between 2 nonmetals is called covalent bonding. We covered that in the previous lesson. So that's going to be our answer for the first question. The next question asks why sodium ions would bond to hydroxide ions, and the reason is that sodium ions are typically positively charged because they're going to lose electrons to become ions. And we just went over that hydroxide ions are negatively charged. So therefore, there's going to be attraction between them, and the attraction is going to create that bond. And lastly, what types of bonding exist in compounds that contain polyatomic ions? Well, let me give you an example to illustrate what I mean by this. So this compound contains a polyatomic ion. This one is called sulfate. You can find it down here. And has a -2 charge, and sodium has a positive charge, so that's why they're going to bond together, is because the sodium is positive and the sulfate is negative, so they're going to bond together. Now this part of the bond that I am putting in red, that is an ionic bond because it's a bond that exists between ions. But the bond that exists here between the sulfur and the oxygen is a bond between two nonmetals. So that bond is going to be covalent. Therefore, the types of bonding that exist in compounds that contain polyatomic ions is both. We've reached the pair up. Please copy down these questions on a separate piece of paper, just right under the do now. We will do these in class tomorrow. And then, of course, once we're finished with the pair up, we're going to switch gears to do the bookwork. And also copy down these summary questions. We'll need these for our classwork as well. Thank you very much. Have a great night.